Lesson 3, Circle Square Patterns. The objectives of this lesson are for you to learn how to reason about patterns and symbols as arbitrary, abstract concepts that can be used to represent numbers. You're also going to learn how to invent a number system using symbols and rules for getting from one pattern to the next. Previously, in AP Computer Science Principles, you sent and received binary messages using a binary message device. As a recap, I'd like to ask you what difficulties were encountered in that, and then think about what is a binary message. Make sure that you remember what that is. So if this was not the recording without class, I would ask for responses. At this time, just think back about what were the difficulties that you had, and then remember, a binary message. It's a message that has only two possible values. Now, what I'd like you to do is on your notebook, on your notebook paper, whatever, write down as many different ways to represent 7 as possible. Use your imagination. You have 5 minutes. Since this is the recorded version of the lesson and not the in-person recording of the in-person lesson, I'm going to keep going. You should pause the video and take 3 to 5 minutes to write down as many different ways that you can think of to represent the number or the value 7. Go. Now that you're back, let's think about different ways to represent 7. Well, notice here, I have 7 sharks. I can also write the number 7. I can do, Roman numerals, right? Okay, or I can, not Roman numerals, I can do score marks. I can do Roman numerals. I could use stars. I could use puppy dogs. I could, if I started out with a circle as being 0 and then however many points on it, so I could have 1, 2, 3, 4, 5, 6, 7. It's a 7-pointed, 7-cornered item. However many corners there are, that's what the number is. So lots of different ways, okay? And again, in class, I'm going to ask everybody for their values. If we kept going, how many ways do you think we could come up with? It should be pretty much an infinite number of ways, right? Why do you think we use the symbols that we do use to represent numbers? Okay, we use the digits 0 through 9. That's how we represent all of our numbers. Who decided that? Do we know? Well, we're going to start looking at Activity Challenge 1. And with a partner, and I'm planning to do breakout rooms. We'll see how this is going to work virtually. If you're in class, I would pair you up. Okay, I want you to work out how many patterns made up of circles and squares can you make with 3 place values. You can also do this individually, okay? These patterns could each represent different pieces of information. What I want you to do is in your journal or in your notebook, on your notebook paper, I want you to write down the patterns. So for example, and you don't have to color them in, they're colored in here just to make it more interesting. I have circle, 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 square, circle. Using just circles and squares, 3 places, how many can you do? I want you to note that order matters. So again, you may do this on your own or with a partner in a breakout room. And we'll see how the breakout rooms work or don't work with Zoom. I do want again to point out that note order matters. So for example, circle, circle, square is different from square, circle, circle, even though they both have 2 circles and 1 square. So go ahead and get started on this challenge. Whoops, sorry, I need to click it over. And again, for this one, I'm going to give you about 5 minutes. Pause the video and complete challenge 1. All right, You're back. Hopefully you've got a list of all the different ways to do it. Now, make sure that you have recorded all of the unique three-place patterns. Okay, so by three-place patterns, I mean if you started out with circle, 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 there's one. What's the next one? Well, you could do square, 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 and then you could do circle, square, circle, etc. So what I want you to do is make sure that you've recorded all of those. How many are there? How many are there? Well, again, if we're in a class, I'm going to call on somebody. And my phone is ringing, so just a second because I want to mute it. Sorry about that. So did you count them up? Did you get 8? There should be 8 unique sequences. Now what I want you to do is I want you to take these sequences and I want you to order them so that the sequence of shapes is predictable. What do I mean by predictable? Well, I want you to write down some rules for which shape should come next. Write down what is the very first line. So in other words, here I put circle, circle, circle. You might have square, square, square. You might have something else. Whatever it is, what I want is that you have some set of rules so that if you show me a line and I follow the rules, my next line would be the same as your next line. Okay? Got it? So go ahead and pause the video. And if your unique patterns are not in some kind of an order that rules can be written about, please put them in an order and then write down how you figured that order out. Again, you can pause the video for 5 to 10 minutes to try this. And you're back. Great. Well, did you record your rules? So what I want you to do is we're going to try testing your rules. And again, if we were in class, I would ask you to exchange them with another group. And then I want you to decide, is it easy to determine the next pattern? Can your classmate easily follow your rules to generate the exact same order that you have? Would your rules work if I only asked you to make them the patterns of length 2? In other words, are they general? What if instead you were asked to make all patterns of length 4 or 5? So if you're watching this video, I want you to pause, and if a parent is willing to do it with you, if another friend or family member would try it, see if they can follow your rules, and then figure out what might be wrong with your rules, if anything. Okay? And again, in class, we'll do this either as a whole group or in breakout rooms. Once you've got your rules and they work all the time, regardless of whether it's 2, 3, or 4 places, guess what? You have just made a number system. Congratulations. We're going to give you one more challenge though. I want you to use your rules to try and generate all possible 4-place value patterns using only circles and squares. 3 examples are listed to the bottom right here. You may need to add new rules or slightly change your rules to account for all 4-place value patterns, but try to keep them as similar as possible to your original. So whatever your original rules were, try to go with that. And again, these, by the way, over here are not in any particular order. Okay? These are just, I've got 4 places and I've either got a circle or a square in each spot. So you want to list it out. So you have 2 items, 4 different ways. Think about it. See if you can do it. Pause the video and give yourself about 10 minutes to try this. We're back. Okay? Let's take a look first here, and then I'm going to go back to the previous page. What should line 3 look like? If line 1 is circle, circle, square, line 2 is square, circle, square. What might this one be? What do you think the rules are? Do we know? We had circle, circle, square. Then we got the square. circle, square. Huh. Well, if I add one more out here, right? If I bump it up, am I going to have square, square, circle? Or should I keep a square on top of this? Think about it. What do you think the next rule should be? What I want to do is come back here and look at, and let's see if I can do this. Give myself a little circle and a little square. And we're going to make the square blue. And we're going to make the circle red. And in person, we would work this out together, since if you're watching this just online because for whatever reason you weren't able to join the class, you're absent, etc., I'm going to give you an opportunity to figure this out. So if I start out and I say that circles are basically like zeros, okay? So that's my circles are less than the blue boxes, right? So I've got all circles. Then my next one would be circle, 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 box. Why box? Because what's one more than a circle? A box. But now, when I do my next line, I'm going to have circle, circle. Now I'm going to up this. So I'm going to go to box, but then this one can go back to a circle. Why? Well, because think about it, if I went up to 10, I would go back to 0 here. Then I'm going to have circle, circle. I have a box, and then I'm going to put a box here. Okay? Notice what's happening. In the next one, I get a circle, but I've already done everything I can with these two. So now here, I'm going to get a box, but these two are going to go back to circles. What do you think this next line would be? Pause the video and try it. And now that you're back, let's try 2 more lines. If you said it should be circle, square, circle, square, you're right, because I'm just bumping it up by 1. Now I'm going to bump it up again, so I'm going to get circle, square, these stay big. This guy's going to get bumped up, and this guy's back down again. See how this works? And then it would keep going. So what are my rules? I start with all circles, and I increase each one by a box. And there's lots of different ways to write this. Okay, and I go from right to left. Could you have started from, instead of right to left, gone left to right? Absolutely. I did right to left just because that's how we normally do numbers. But we also read from left to right. So that would have worked as well. You just have to stay consistent with your rules and your patterns. Now, as a wrap-up, I want you to jot down in your notebook and be prepared to share in a few minutes your answer to this prompt. How is counting in this circle and square system similar to how we count in our regular lives? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, etc. So how is it similar and how is it different? I'm going to be asking for people to share out their answers to this prompt at the beginning of our next lesson. Thanks.